Hi, my name is Shaheen. I'm going to show you how you can use Predixion software to deploy predictive analytics using Helix Device Cloud or HDC. Predixion offers an easy deployment tool that empowers the users to deploy a predictive analytics package to a device. This helps you take the power of predictive analytics to Internet of Things without the need for complex operations or costly development. Imagine a predictive maintenance scenario in which a model is trained to generate an alert whenever an oil pump is going to have a failure in the next few hours. We want to be able to collect data from hundreds of sensors on the pump, calculate the probability of failure, and report the outcome to a dashboard. In an IoT scenario, you will have hundreds or maybe thousands of such smart devices running predictive models. There are many tools that offer edge management systems. I'm going to talk about Helix Device Cloud or HDC by Windriver. HDC allows you to view your managed devices, put them in various categories, and look at their status. It also enables you to send a file to the device, execute a command, and receive alerts from the managed devices. Let's take a look. I can go to the Assets page, look for the assets that are categorized under Predixion Assets category, and at a glance, I can see that the status of all my assets as indicated by the green icon are good. For this demo, I'm using a model that has been trained on data collected from an electronic submersible pump in an oil well. Let's take a look at my predictive maintenance dashboard. Here I can see my assets with the probability of failure in two different time windows, one short period of 5 minutes and one long period of 14 days. These probabilities and respective time windows are a result of design time decisions in creating the predictive model. While the short-term predictions can help avoid failure that can be very costly or disastrous, the long-term model can help a more efficient planning for services and maintenance. Let's check the details of the assets. I can see the charts with historic values of the probabilities of failure. I can also check the influencers for the failure such as pressure and temperature. I can see the list of packages that have been delivered to the asset, along with events and audit logs. If a sensor reading such as high pressure occurs, that could result in the model predicting a failure, and the probabilities of the failure will start to increase. Here you can see that this pump is predicting a high risk of failure in the next 5 minutes. The model has already sent an alert to the system that has set the status of the asset to red. This automatic alert can also shut down the pump and send a notification via text message or push notification to designated users. I can view the location of the oil well on a map and, if required, add maintenance action and assign it to a maintenance group. I can optimize the maintenance plan and reduce overhead. I can also go back to the Assets Details page by clicking the Details button to check the probabilities and possible influencers for the failure. This is an example of Prediction's ability to easily embed predictive models onto many devices to support challenging use cases presented by the Internet of Things or IoT. Let's see how it works. Predixion provides a powerful and innovative platform to create and deploy predictive models into production environments by integrating various technologies. In this case, two models have been trained to predict failure based on sensor readings, a short-term and a long-term model. I can go to the Deployment Assistant, choose my desired model inputs and outputs, I can then click on Device Execution, select my target as Helix Device Cloud among other targets, provide the group of assets that are the target of this deployment, and specify the frequency of model execution. I can use existing input-output connectors or add new ones that match my setup. This extremely flexible architecture allows for development of any new custom connectors that can be used either for inputs or outputs. I can then provide sensor bindings to my selected inputs using a variety of technologies including MQTT. I will also choose output bindings, which specifies how the model outputs are going to be consumed, including AMQP that can be used to send the result to an Azure Event Hub. Once the settings are done, all I need to do is to click Deploy. The Predixion server now sends the required settings to the Helix Device Cloud, where all the assets in my target group will then be updated with the new settings. I can also check the progress of the deployment via HDC. So what you see is an example of Predixion deploying a predictive model using an edge management system to a group of assets without the need to write extra code. The result of the model can then be easily extracted for further action to achieve predictive maintenance. In this case, the edge management system is HDC and the assets are oil pumps, but the possibilities are endless. Thank you.